Hi, morning everyone. Today we are learning about how to measure the hysteresis loss of a given ferromagnetic material by drawing B.H. curve. Here the ferromagnetic material has the hysteresis nature that can be shown by using CRO. CRO means cathode ray oscilloscope, which visualize the electrical and magnetic component values. And here we are taking ferromagnetic material in the form of toroid, that means turning into a certain number of coils on a copper coil or anything, and here we are taking the ferromagnetic coil as a toroid N1, so input coil, and this is output coil where it is called as a N2 coil. We are applying the magnetizing field H to the input coil, is called X coil, that is also called primary coil. The N2 coil is also called as secondary coil. Number of turns in primary coil is N1, number of turns in secondary coil is N2. And this primary input X is given to X CRO input, and secondary coil connections is given Y, called as Y input. This Y input given to Y CRO. These connections are to be made. This coil board connections to CRO board connections. Once it is over, now how the magnetic induction is varying in accordance with the applied magnetic field H. The applied magnetic field H is increasing from 0 to positive side along X direction. Then you are observing that magnetic induction B also increases along the points up to A. Once it reaches A, the magnetic induction Bs value does not increase and remains constant, whatever the value of which increases. So this value is called as a saturated magnetizing induction, and this saturated magnetic induction is reaching. So we will no use of increasing H, we will take back H value to the 0, but Bs value does not reach in 0, but it stay at Br value, that is point B on the curve, and this Br is nothing but called as residual magnetic induction or retentivity. Now we can define retentivity. The magnetic induction left in the sample, even the applied magnetizing field is removed, is called magnetic retentivity or residual magnetic induction. This residual magnetic induction is made to 0 by applying negative magnetizing field H into the negative magnetizing field minus H. This is called coercive magnetizing field or coercive force. This coercive force is represented with minus Hc, and the point is C. And once the magnetizing field H is negative value, Br value is reaching to 0, and thereafter increasing Hc value beyond minus Hc, there is increase in B value in negative side up to D, and it reaches negative saturated magnetic induction. There is no use of increasing in this direction, hence we are redirect the H value into the 0 side. As H value is taken to 0 side from D to O, the value of B is moving from Bs to Br, means negative retentivity is obtained once again. And now to make the negative retentivity to 0, we need to apply positive H. This positive H is obtained at F plus Hc, and thereafter increasing H, the magnetic induction reaching point A. So whenever you are changing H value between A and D, the B value is changing from Bs2 plus Bs2 minus Bs, like this. Only every time we are getting this curve. This curve is called as a B.H. curve. and why it is called as a hysteresis curve. At every point on the curve, if we observe the values of h and b value retains back the h value, means h moving forward and backward b is moving. What it means that b is historic position of h. Hence this curve is named as a hysteresis loop. Now we are calculating here the h is 0 but b value is not 0, it is retained back to the Br. So this much of loss of energy is taking place. This energy in the magnetic induction is called as an hysteresis loss. We will calculate hysteresis loss by applying experimental formula as we explained like this. So we will calculate the hysteresis loss of the ferromagnetic material by this formula. N1 by N2, R2 by R1, C2 by V, SH, SV, A. What are this representing? Let us see. N1 and N2 are number of turns in primary and secondary coil. This were represented on the coil board. We will see this. What are the values on the coil board? R1 and R2 resistances in primary and secondary circuits. This R1 and R2 values also we can notice from the board. C2 capacitance in secondary circuit. This capacitance value is also noticed on the board. Now SH and SV is related to sensitivity of horizontal and vertical of CRO. And this sensitivity of H, sensitivity of vertical is calculated by the formula where we are taking here SH is equal to 2 root 2 Vx by Lx. What is mean by Vx? Vx is nothing but X input voltage of the CRO. And what is Lx? X signal length or X curve length, where we are making Y to ground. And Vy input voltage of CRO, Y signal length or Y curve length obtained by making X as ground. And this is the calculation of SH and SV. Now what is A? Area of loop. This area of loop is calculating from the graph by tracing this curve, BH curve on the trace paper and transfer to the graph paper, and we will count number of small squares that will give the area of loop. We will do this one in practical. Next, B, volume of ferromagnetic material. This volume of ferromagnetic material is a fixed value. That value is given by 4.95 10 power minus 5 meter cube. Hello, come to the real apparatus. This is CRO, cathode ray oscilloscope, which can displace the BH curve on this screen. Here we have a BH curve, what I shown in the previous explanation. In the same way the curve is obtained, and here there are connections. This is called Y connection. Here it is Y connection, and here X connection, and this is channel 1 voltage, this is channel 2 voltage, and channel 1, channel 2 voltages. Channel 1 means Y input, channel 2 means X input. These voltages are also mentioned here. And now we will connect this CRO connections. X input connections are connected to X input of circuit board, and Y input connections are given Y input of a CRO. Now you are seeing that this is X input. This X input is connecting to X inputs of board. Here see that X CRO is there here on the board, and X ground is there on the board. The X CRO is connected red wire, X ground CRO is connected to black wire of the CRO X. And similarly Y input of the CRO is connected to Y CRO. Here this is the Y CRO red, and this is Y CRO ground, and the Y CRO ground is connected here. And this side coil is called as a primary coil. This side is called as a secondary circuit. This circuit is called as a primary circuit. And here we are observing that what is the resistance. You are connected, the primary resistance R1 is 10 ohm, and secondary resistance here it is 680 ohm. This is mentioning here, and that is R1 and R2. Now N1 and N2, number of turns in the coil, it is mentioned here, it is N1 is equal to 200, number of turns in the secondary coil, N2 is equal to 100. Capacitance C2, here it is mentioned capacitance symbol, and 4.7 microfarad. And this is the values what you are noticed from this circuit board. So what are the values are getting from circuit board? N1, N2, R1, R2 and C2. That values are from circuit. And Vx, Vy for sensitivities, Vx is channel 2 voltage, that is CH2 voltage. Vy channel 1 voltage, that is 0.2 volts. Like that you can note the Vx and Vy. How to get Lx? To get Lx, here you see that Y input has two knobs. The two knobs, one knob is ground. You make this as a ground press like this. What you are seeing that this X input is make ground. We have vertical line length. And if you can open this one, and you are getting same curve. If you can make YCRO to ground, this is Y connection. Channel 1 is Y connection. Channel 1 is Y connection is connected to ground, pressing the ground. So we have horizontal line. This length is measured, that is called Lx. And you want Ly, you can take Lx to be ground. Lx is grounded, so we have Ly. This length is called as a Ly, 4 centimeter. So now you have Lx, Ly, everything. And now you can use a trace paper, and you put a trace paper on this one and copy the curve onto the trace paper. And this trace paper is placed on the graph, and we will draw the graph like this. You see this is the trace paper. This is the trace paper. We will keep the trace paper on this like this, and we will curve to be copied like this. Making center point, this is horizontal, this is vertical, and this curve is to be placed on the graph paper and calculated the number of small squares. That value will give the area of the loop, and volume of the loop is given. Substituting all the values, we will get the hysteresis loss of a ferromagnetic material where we are used in this coil. Thank you.